Sorry, YouTube Nation, I forgot to start recording this, but there's the first problem worked out. We're doing, yeah, we're modeling with equations. This is a consecutive number type problem. Now we're looking for two consecutive squares whose sum is 613. Well, that's a little bit trickier, huh? So two consecutive squares. First, I need two squares. Give me an example of two squares that are consecutive squares. Okay, so 4 and 9. Okay, so you said 2 squared and 3 squared. Good. So I need to write now an expression with variables. So let's call one x squared. What would the next one be? So some people say x squared plus 1. Very good. It's x plus 1 quantity squared. Okay? It's the next integer squared. So we are going to sum those to 613. So x squared plus the quantity x plus 1 squared is 613. So x squared plus 2x plus 1 is 613. So I had to FOIL that out. I have 2x squareds plus 2x is, so I'll subtract this 613 to get minus 612. Why did I make it equal to 0? Yep, use the zero product property. Two numbers that multiply, negative 306 that add to 1. Natalie's got it. She's smiling. Well, they must be pretty close together, right? Because, you know, they differ by positive 1. So if I just take the square root of 306, that's surely to give me a number that's close. 17 and 18 sounds good to me. Let's try it. 17 times 18, and what do you know? There you go. Sweet. So my solutions are? I'm done, right? What does the problem ask for? Those are not consecutive squares, so what should I do? Very interesting. Let's see what happens. I'm going to take negative 18 and plug it in. Negative 18 squared. Very good, 324. And then negative 18 plus 1. Negative 17 squared. 289. Those are consecutive, right? I just tried that. Now let's try 17. 17 squared. And 17 plus 1. Wow. Isn't it incredible that the mathematics accounted for two different ways to come up with the consecutive squares, both the positive and the negative? Because when you square something, it's going to be positive. I mean, we are always inferior to mathematics, are we not? I mean, it's ahead of us. Yes. Yeah, very good. So if you notice, we have, say, 4, 9, 16, 25. And so that would be 2 squared, 3 squared, 4 squared, 5 squared. So a lot of times people say that, you know, x squared is the first one, and then x squared plus 1 will be the second one, right? Well, watch what happens. If you plug in a number like 5, well, what's 5 squared? Well, 5 squared plus 1 is, yeah, you get 25 and 26. Well, those aren't consecutive squares. So we have to rephrase what we're doing. X squared, and then this would be x plus 1. It's 1 more that we're squaring. And then it's 2 more that we're squaring. Then it's 3 more that we're squaring. So now if you plug in 2 here, 2 squared is 4. 2 plus 1, 3 squared is 9. 2 plus 2 is 4 squared, 16. So do you see it now? Okay. Did you say no? Whoa, all right, awesome. Math is awesome! All right, here we go. A rectangular garden has a perimeter of 288. The length is 4 more than twice the width. What are the dimensions of the garden? Oh my goodness! Who plants a garden and thinks through this stuff? I mean, really? Okay. So what should we do? Draw a picture. Thank you, Anna. So loud today, Anna. Now what? Now what? Okay. Or how about W? I like that. The length, look at how the English just spells out first. The length is 4 more than twice the width. Like, it's there. All right, so what do I do? Add them all together. W plus 2W plus 4 plus another W plus 2W plus 4 is 288. Why do I have twice as many? Yeah, the other side's going all the way around. How many W's do we have now? 6 W's plus 8 is 288. So 6W is 280. W is 6, let's see, 280 divided by 6. Hand it any calculator. All right, thank you for being quick with that. 46.6 repeating. I'm done, right? Very good. It says the dimension, so let us find the length as well. 2 times 46.6 repeating plus 4, 97 1/3. And we should put a label there. That's a big old garden. We all good? We go through example 7 today. We missed some time on Friday due to evacuation. Okay? Yes. Okay, so we go to example 4. Let's. I'm going to draw myself a box with an open top because I was an art major, very gifted. And so here we go. A box with a square base and no top. I'm open. There you go. Okay, all right. Okay. All right, here we go. Olivia is me. Here, take that. Okay. All right, very good. All right, so now we want a square piece of cardboard that we're going to use to make that. So I've got a square piece of cardboard, and I cut off, okay, a 4x4 off of each edge, right? Okay. Cutting a 4x4 off of each corner. It says the box holds 100 cubic inches. How big a piece of cardboard is needed from the beginning? Oh my goodness. 100 cubic inches. What does that measure? How do we calculate volume? Length times width times height. So I need all these dimensions, right? Do we know this dimension? It's 4. That's what we folded up, right? If we cut 4 off, then that's going to be what we fold up. Everybody agreed? If you cut, so So like these are going to be the edges, and when you take this and fold it up like that, it's going to be 4 tall, right? So I've got that. We don't know what this original dimension is, do we? But we do know it's the same as that. So this dimension right here, is that going to be less than x, the same as x, or greater than x? I ripped something off. Like it started as x, but then I ripped 4 off there and 4 off there, so it's x minus 8. Wow, okay. Way to go, Jessica. Well, now I have an expression for volume. Volume is how much? Length times width times height. So I multiply all those together, I get 4 times x minus 8 quantity squared. Y'all good there? Base times width times height. Multiply all 3 together. Can I solve this? What do I do? 25 equals x minus 8, quantity squared. It's okay. Now what? Okay, so if I square root, I get plus or minus 5 because I'm solving for x, so I have to account for 2 solutions. Equals x minus 8. Add the 8, and I get x is 8 plus or minus 5. So what are my solutions? So are they both possibilities or just one a possibility? Why just 13? Yeah, so 13 inches by 13 inches is what we want it to be. But what's interesting is if you have x be 3, 3 minus 8 is negative 5, and 3 minus 8 is negative 5. So negative 5 by negative 5 by 4 is still 100. So we can't have a negative dimension in our limited world, can we? But in mathematics, why couldn't you have a negative dimension? There's no limitations on space or anything like that. And so again, mathematics is above us, and we are just peons trying to figure it out. So, all right, a couple more problems. A right triangle has a hypotenuse. What? If you were to plug in 3, 3 minus 8 gives you negative 5. So it would be saying that your width is negative 5. And that's not reasonable. Although you could have a 3 by 3 piece of cardboard, that would not give you. All right. Right triangle has hypotenuse of length 12.5. One leg is 8.5 inches longer than the other. What is the area? Somebody help me out, please. Nice job, Natalie. Is everybody okay with that? Now what? Okay, so you want to do area is okay. Yes, can I show you an easy way to remember that it's base times height divided by 2? So if we take our old rectangle here, we all remember that if you take base times height, you're going to get the area of that, right? So then we just slice her in half, and that's our area for a, yep. No, it's okay. No, it's a great question, and we honor that. So way to go, Natalie. All right, so, all right, so I got a formula. So now what? So 1/2 times x plus 8.5. Somebody here is thinking it. They just are refusing to speak up. Say it. What'd you say, Liz? Okay, that's a thought. Starts with a P. Pythagorean theorem. Thank you. Yeah. And that's, I mean, that's what has to happen, folks. It's called the aha moment. I can show you examples, but at some point that aha moment has to occur for you on your own. Okay? So we got a squared plus b squared is c squared. The Pythagorean theorem. Pythagoras, great mathematician and a great thinker of the Greek classical era. He had a following of people, the Pythagoreans. You should do a study on them. They're amazing. They love their mathematics. They love their music. I should say that they were not the only people to come up with this relationship. People in the Chinese culture were able to do so as well. People in Egypt were able to as well. So quite a group of people came up with that independently of each other. It's not like he was the only one that did it. If you haven't seen the proof for that it's pretty cool and it's easy to kind of see. But anyway, let's do it. X squared plus x plus 8.5 squared is equal to 12.5 squared. So I've got x squared plus what's the middle going to be? 17x plus 72.25 is equal to 156.25. Thank you to the woman in back with the calculator. 2x squared plus 17x. I'll subtract the 160 or 156.25 over, and I get negative 84. Ooh, does it factor? You feel like it does. All right, let's take our chances then. At 2 and 42, 4 and 21. Is it divisible by 3? 4 and 21? But you got to multiply by 2. Is it 3? How do we know it's divisible by 3? Because 8 plus 4 is 12, and that's divisible by 3. So we know it's divisible by 3, so we got 3 and 28. I don't think that's going to work. If it's divisible by 3 and it's divisible by 4, then it's divisible by, or 12, 6 or 12. So 12 would give me 7. I think I like that one. So if I could get a 12 over here, if I could get a minus 7 there. $3.5 and negative 12, huh? Right? So is that my answer? I'm trying to find what? The area. I want to know the area. This is what I'm working with. So if x is 3.5, what's the base? 3.5 plus 8.5 is 12. So we got 1/2 times 12 times 3.5. 1/2 of 12 is 6 times 3.5. 21 inches squared. Kind of a cool one, huh? 2 more left. This should be 5 meters, not 5 feet. We'll see if you guys can take me down this path, too. We kind of hit a roadblock last time. Maybe we do a better job here. A man is walking away from a lamppost with a light source 6 meters above the ground. Man's 2 meters tall. How far from the lamppost is the man when his shadow is 5 meters long. Draw the lamppost. Charlie's taking us away. Lamppost. Person. Shadows. That's 5. His lamppost is 6. He's 2. Or D for distance. Six over D is 2 over 5. There's 2 triangles. Are the triangles similar? How do you know? They share an angle, and they both have a right angle. And if 2 angles are the same, then the third angle is the same. Then you won't be able to get it. If 2 triangles are similar, then their sides are proportional. So if I take the heights and divide it by the lengths, hopefully it'll work out. What's the height of the dude? 2. Which apparently half of his height happens to be his neck. Okay? Divided by the length is 5 equals the height of the 6 over D plus 5. Cross multiply. So he's 10 meters. 10 meters away from the lamppost. So, yeah, exactly. So, Gigi, if you would have set it up like that, you came up with 15 and you subtract off the 5. That's what's hard to see. Okay, one last example. For some of you, this will cause you to possibly shed tears, okay? But I promise you we're going to do problems even more challenging than this. And this is that kind of that point where you guys have to remember, you're all nice kids. I like you. But just because you're a nice kid doesn't guarantee that you're going to understand it. You're going to have to work through points of confusion. You got to be able to climb that mountain of confusion. I can't do it for you. I could be there with you. I could give you some oxygen. I could throw you a rope. But ultimately, you got to work through some of those points on your own, okay? Now, I will say one last thing. If you need help with some of these problems, I'm available. But you got to come in and see me, okay? So, otherwise, I'd just assume you know how to do everything. So here we go. 2 flagpoles have heights of 9 and 13. It's a poorly worded sentence. I must have been watching football or something. Ropes connect from the top of the poles to the other's base. That's what that's more or less supposed to say. How far from the ground do the ropes cross? Now, I gave that question to some math teachers. I've solved it 3 different ways, one by using similar triangles, and it was complicated enough where I don't think we'd really understand it at all. As I gave it to the other math teachers, they all failed to find an easy way to solve it, and we all agreed that the easiest way to solve it is what I'm going to show you. And so you may say, well, why are we doing that? I think it's often an excellent way to tackle these type of problems. Sometimes if we get in geometrical situations, it might be easier to place things like this onto a coordinate plane. And so I'm going to put it on an XY axis where I make this spot 0, 0, or the origin. And now I've made that problem into something that's a little bit more simple. In fact, I'm just looking at the intersection of two what? Two lines. We have line 1 and we have line 2. And when I find the intersection of 2 lines, I'm finding an XY value. Which value will tell me how high above the ground they intersect? The Y value. That's what I'm looking for. So let's just write an equation for 2 lines. We'll start with the first one. I'll start with the blue one. Y is equal to mx plus b. What does b represent in that type of problem? The y-intercept, right? And as you look at the blue line, what is the y-intercept? 0. So now we just have y is equal to mx. What does m represent? The slope. And in 2 words, slope is actually 3 words. 2 of them have r. Rise over run. So what would I rise to get from here to here? 13. What do I run? We don't know. Some distance we call d. So we'll say that y is equal to 13 is my rise, d is my run, and we'll call it x. Okay, I don't like the d, but I don't know what else to do, so I'm just going to roll with it. So we'll do line 2. Y equals, trying to stay color-coded here. Y equals mx plus b. B is the y-intercept. What's the y-intercept for the red line? 9. That's going to be a 9, right? Y equals mx plus 9. Slope. What do I rise to get from here to here? -9, right? And my run is d. So y equals -9 over d times x plus 9. I now have an equation for 2 lines. I'm trying to find the intersection. How do I find intersection between 2 lines? We've got 2 options. Suppose I have 2 lines like that. How do I find the intersection? I could graph it. Substitution. So since y is equal to that, I can plug it in for y. So substitution is one option, right? Suppose I have this. 2x minus 3y is equal to 6, and 4x plus 3y is equal to 0. What do I do there? Yeah, that's called elimination, right? So we have elimination or we have substitution. Those are 2 options. So what am I going to use in this situation? I use substitution. Okay? So I will say this goes here. 13 over d times x is equal to -9 over d times x plus 9. What coordinate am I trying to solve for right now? The x or the y in this part? Trying to solve for x. The y's are gone, so I'm trying to solve for x. Okay? Well, I'm going to get all the x's on one side, so I'll add a 9 over dx, add a 9 over dx. And what do I get? 22 over dx, very good. It's okay. It's equal to 9. How do I solve for x? D over 22. And when you do that, notice you get x is equal to 9d divided by 22. Okay, still not a fan of the d, but it's there. The answer to the problem you said would be which value? The y value. Once we have the x value, how do we find the y value? Is it going to be easier to plug this in for the blue equation or the red equation? The blue. And so we say that y is equal to 13 over d times our x value, which is 9d over 22. Oh, what happens to the d's? Oh, isn't that nice? And we get 13 times 9, 117 divided by 22. Which is approximately 5.31 feet. So, you know what's really interesting about that? Does it matter how close or far apart the poles are? No. The height of the intersection will always be at 117 over 22. If I do push it out further, that will change the x value of the intersection, but the y value will always remain that. It's kind of interesting. So I know that that's probably very new for you. And I know at first glance, maybe like, that's ridiculous. But it's new. Once you try in your homework assignment, and then once you try on the study guide, you might be like, oh, hey, this really isn't that bad. In fact, I think I could do this. So that leaves us to your assignment, which is on your worksheet, problems 1 through